Okay. Here we go. So we talked about the hypersensitivity type 1, which is allergy, mediated by immunoglobulin E. Hypersensitivity type 2 mediated by immunoglobulin G. Oh, sorry about that. Mediated by immunoglobulin G. Okay? So the example of type 2 hypersensitivity is the transfusion reaction. And we're going to quickly go over it and go over the blood types. So how many blood types we have? Well, 52 actually. Yeah, 52 different antigenic groups. Different types of blood antigen, we have 52, but we're going to talk about 4 blood groups. Reaction, RxN. Well, let me put the full one. Okay, so we have 4 different blood types. Okay, one blood type has both A and B antigen. These antigens are called agglutinogens. My bad. Agglutinogens. Okay. One type has only A, one type has only B, and another type has nothing. Okay? So the first one will be what blood type? AB. Next one, A, B, and O. That makes sense? Good. Interestingly enough, so these antigens are on the red blood cells. Interestingly enough, every blood has antibodies in the plasma. So antibodies must not interact with antigens that are present on red blood cells. So for instance, the blood type A has antibodies against B. Does that make sense? Blood type B has antibodies against A. So type AB, would it have any antibodies? No. What about type O? A and B. Now, what would happen if you mix A blood type, every red blood cells, if you would take red blood cells from somebody type A, okay, and inject it, transfuse it into type B. What? No rejection, no. It wouldn't be a rejection, it would be something else. It's called agglutination, coagulation. Not coagulation, because coagulation is a specific process. Sorry. So, how? What will it interact with in the type B person? Huh? Antibodies, yes. Does that make sense? To A, yes. Does it make sense? You got it? So here, what we do, we take red blood cells that are type A and put them in a person who is type B. the antibodies in this person's plasma will interact with A antigen and agglutinate the blood cells. Does that make sense? What do you mean? Oh, that's a great question. So what about antibodies against B that will be transfused as well? The amount of antibodies that the amount of plasma that you transfuse is little compared to the number of red blood cells in the recipient. So, will there be a reaction? Yes. Will it be a noticeable reaction? No. Does that make sense? Because transfusion mostly involves red blood cells. Oxygen carrying cells. Does that make sense? Okay. So which blood type you can transfuse, which red blood cells you can transfuse to everybody? O. Which blood type can receive any red blood cells? AB. Does that make sense? Mm-hmm. Yes. See? Yeah, because antibodies will start to clump cells together. And macrophages will start to kill them. And you're going to have cell lysis and hypoxia and kidney failure. That's all transfusion reactions. Does that make sense? High fever and really shitty situation. Does that make sense? Now, these are pre-existing antibodies and pre-existing antigens. Okay? The next thing that I want to discuss quickly is the rhesus factor. It was isolated in rhesus macaques, okay? And there are two types of blood. One that has the rhesus factor and is called rhesus positive, and another one that doesn't. It's called rhesus negative. Okay? Does that make sense? That idea. We have no pre-existing antibodies to rhesus factor. Sorry. Red blood cell. Okay? So we have no pre-existing antibodies to rhesus factor. Neither rhesus positive people nor rhesus negative. Now what will happen if you will mix rhesus positive and rhesus negative blood? Huh? If the rhesus positive going to be donor and rhesus negative is going to be recipient, okay? Recipient will develop antibodies, anti-rhesus antibodies. Does that make sense? So if you transfuse rhesus negative into rhesus positive, are there going to be any antibodies formed? No. If you transfuse rhesus positive in rhesus negative, the answer is yes. Does that make sense? We're getting there. Why we talk about rhesus antibodies? Because of the rhesus conflict. It happens when you have rhesus negative mom. I don't even try to picture a human. So I'm going to represent humans with the circles, okay? You have rhesus negative mom and rhesus positive child. Okay? So do anyone in this pair, that's the first pregnancy, does anyone have antibodies here? No. The red blood cells of a child and red blood cells of a mom, can they cross placenta? red blood cells. No, they can't. Oxygen, things like that can, cells cannot. Okay? They're isolated, they feel fine. And then what usually happens after 9 months of pregnancy? The birth. Okay. So during the birth, baby comes out. Okay? What happens is placenta detaches, and for a fairly short period of time, the fetal blood and mother's blood become mutually exposed, which means that rhesus-positive red blood cells spill over into the mother's circulation. Does that make sense? So they're rhesus-positive, they have antigen. Mother's immune system, what it's going to do? It's forming antibodies. Okay, so you have anti-rhesus now. Antibodies. Does that make sense? Baby's already born. Is there anything bad about it? No. Baby's fine. And then mother decides to go with a second pregnancy and has the same situation. Rhesus-negative mother, rhesus-positive fetus. Can immunoglobulins, IgG, cross placenta? They can, and anti-rhesus antibodies will attack babies, well, fetal red blood cells. This is called, the disease is called hemolytic disease of newborns. Sorry, my handwriting went completely south. Or, fancy name, again, handwriting, erythroblastosis fetalis. This is T, okay? Fetalis. How you treat it? No. If it's already there, you treat it with transfusions. How do you prevent it? ROGAM. Here's what ROGAM does. ROGAM are surprisingly antibodies against rhesus factor. Okay? So here's what happens. I will try to explain it. Actually, I'm gonna have to maybe remove some of that stuff, if you don't mind. Okay, put it here. Okay, so here's mom. Here is baby. Okay, rhesus-positive baby that is spilling its red blood cells into the mom's circulation. Okay, but mother has been passively immunized with anti-rhesus antibodies. Passively. So what this, when an exogenous anti-rhesus antibodies encounter red blood cells from the baby, what they're going to do? They're going to bind them, right? They're going to bind them. Okay? So antibody, exogenous antibody from the shot will bind those red blood cells and completely mask rhesus antigen. Mom's immune system, will her immune system see the antigen now? No, because they're covered by the antibodies. Does that make sense? Okay? I don't know the exact procedure, but yeah. So, masking antigen. Does it make sense? Right? So every time, if you get married, ask your significant other about the blood group. So you better do match. Okay? You better do match. Because if they're unmatched, and mother has negative and father has positive, there's a good chance the child will have positive. Okay? Awesome. Bring the quiz on Monday. We'll go over it.